Well, happy Thursday, ladies and gentlemen. My name is Mr. Royce, and I will be your video sub. Once again, we have a live sub in the room. Let's begin by getting ready for assignment 6.6, which is due on Thursday. So, for today, what you need is your handout lesson plan for assignment 6.6. You should already have that. Live sub has a couple extra copies in case you don't. Also, you're going to need Formula Central, so take that out, please. And also, you should have just picked up your assignment 6.4, which is graded, and you should have just turned in assignment 6.5 to the table right here by the computer. So, take out assignment 6.4. I have just a couple of comments on that. And while you're getting that out, remember, Truth Seekers today after school in room 2900. I do recommend you look at the PowerPoint presentations for chapter 15. They're online. We're going to go over 6.4 right now. 6.5 you just turned in. We're doing a hot dog problem today. So live sub and video sub are going to team up. This will be the first ever attempt at a collaboration between live sub and video sub to conduct a hot dog problem. Today's the day. We're going to try that. And by the way, tomorrow the quiz, that's on assignment 6. It's just going to cover assignment 6.1 through 6.3. So it's not the stuff we've been doing this week. Tomorrow's quiz is pretty straightforward. Make sure that you check your conditions for launch before pressing that launch button on tomorrow's quiz. So, we've also got a problem that we're doing today on a blank sheet of student supplied paper. So you need your handout lesson plan for assignment 6.6. The blank sheet of paper and Formula Central, you should be good to go. Your hot dog problems also. So here we go. Just a couple of comments on assignment 6.4, which is the homework that I graded for you last night. Take a look at assignment 6.4. A lot of people messed up the Canada but not Mexico problem. That's problem 2. The best way to approach that problem with Canada and Mexico would have been to sketch a Venn diagram or a two-way table or something. But the most common mistake that people made was when they said 9% of the people traveled to Mexico. That means the football and the cookie add up to 9%. Some of you put 9% in the cookie when it should have been 5% in the cookie. The way you know that is because they told you that 4% travel to both Mexico and Canada, so that tells you the football is 4%. Subtract that from the 9% that they gave you to get 5% over here. So that's a little coaching issue there. And it looks as though on B, in case, I try to give you credit for correct use of incorrect answer, but on problem 2, letter B, in order to find the probability of Canada or Mexico, which is Canada Union Mexico, you take probability of Canada plus probability of Mexico minus the football. Some of you forgot to subtract the football, so it ends up being 0.18 plus 0.09 minus the football gives you an answer of 0.23. By the way, back on part A, the probability of Canada and not Mexico was probability of Canada, which was 0.18, and not Mexico, you have to end up subtracting off the 0.04. So Canada, but not Mexico, essentially means you take Canada, subtract off the football, and you're left with .14 was the answer to part A. So that's part A and part B. And on part C, you ended up taking probably neither Canada nor Mexico. Take 1 minus the union, which was the answer to the previous problem. Part C, you take 1 minus the answer to part B to get .77. And then briefly, on the PET problem, those of you who missed portions of number 8, most of you got number 8 correct. I was proud of you for that, but the probability of male given cat. Look at formula central. Formula number 5, probability of A given B, is the hardest formula for some of you to work with. And so that's my main goal today, is for you to feel much better about formula 5 on formula central, probability of A given B. Here's an application of it. Probability of a male given that it's a cat. Now, formula central says take the intersection and divide by the probability of whatever comes after the slash. What does that mean in terms of a two-way table? Probability of male intersect cat. It means we take the probability of, take male, where does that overlap with cat? So, that's 6, but you take that out of the total 42, so it's, or you can just say, look, 6 out of the total 42, and the probability of cat, take the total cats, which is 18 out of 42, is that probability. So notice these are just counts. They have not yet converted this table into a frequency table. Some of you who got it correct just did the probability of male given cat is you took the cat sub-universe, shrink the universe down to whatever comes after the slash. And so you just did 6 over 18. Either way, the answer is 1/3. The probability of cat given female is cat intersect female over the probability of female. One way to do it is to take 12 40-seconds over 28 40-seconds. Others of you just viewed it directly as 12 divided by 48, 12 divided by 28. Intersection over the row total. Notice this one was intersection over the column total. That one was intersection over row total. Some of you reduced it to fraction 3/8. Others of you put it in decimal form, about .429. And for those of you who missed part C, probability of female given dog, take the intersection over the probability of whatever comes after the slash. It came out to .667 or 2/3. So if you want additional help on those, I'll be available tomorrow morning, Thursday morning before school, over in room 1514 between 7:30 and 8 o'clock. So let's work more with Formula 5. On the blank sheet of paper that I asked you to take out, please write down the following classic problem. This is the HIV positive problem. This is where you go to get tested to see if you're HIV positive or not. Now, this is the sort of problem that hopefully you can't relate to directly, but you can certainly imagine going and getting a test, and the outcome of the test is either positive or negative. Sometimes you get a false positive, meaning that they tell you, yes, you have the disease, but really you don't. Sometimes you get a false negative, which is where they say, no, your test result is negative, you don't have the disease, but actually you do. So this kind of setting is what we're going to use to understand Formula 5 from Formula Central. That's the probability of A given B, A/B formula. And then I'm going to ask you a hot dog question, and Live Sub will help me figure out whether you deserve credit for that. So here we go. This is the HIV problem on your blank sheet of student supplied paper. Let's take a look at this. Have Formula Central right next to you. Suppose we have a situation in which, in reality, you either have a disease, we'll call it D, or disease complement. Now, you don't really know whether you have the disease, but suppose that in reality, from an objective perspective, 10% of the population has a disease, 0.1. And 0.9, 90% does not have the disease. You're writing this on your sheet of student supplied paper. Now, the hot dog problem we do today will be similar to this. Now, what you do, see, the people who have the disease, they go and they take this test to see whether, it's a positive test result is a message that you do have the disease, positive or negative. Negative is you don't have the disease. So suppose that for people who have the disease, here's how the test performs. 80% of the time it gives a true positive, and 20% of the time the test says, no, you don't have the disease. It's telling you a lie. Even though you do have the disease, it's saying, no, you don't. Now, the test performs differently for people who do not have the disease. Disease complement, positive, negative. For people who don't have the disease, it says, 70% of the time it gives you a positive test result, and 30% of the time it's okay, yeah, that's crazy. It's giving you a false positive. Okay, sorry, that's unacceptable. We just can't do this. It's not realistic. Let's say that it tells the truth. Change that to 0.7. 70% of the time, when you do not have the disease, the test tells you the truth and says you do not have the disease. Negative test result. It tells the truth 70% of the time. It lies to you. It says, hey, you've got AIDS, even though you don't have AIDS. So that's upsetting. It gives you what's called a false positive. So right there, this leaf is going to be the false negative probability leaf. This is going to be the false positive. If you do upper branch times lower branch equals leaf, you can fill in all of these probabilities. These 4 leaves should add up to the number 1. Go ahead and fill them in by doing branch times branch equals leaf on each one. Then when you're done, look up at the screen to see if we agree. Okay, hopefully you have these filled in by now, and you've got 0.08, 0.02, 0.27, 0.63. We just did branch times branch equals leaf on each one. Now, there's a variety of questions that we can ask you based on this tree diagram, some of which, for some of these, you will need central formula number 5. Let's take a look at some of the questions that we would commonly ask you. Question 1. And the hot dog question today will be like one of these. So we're practicing right now for the hot dog game. All right, here we go. Just want to make sure the camera's recording sometimes. Yep, still recording. Okay, that's good news. Now, we might ask you something like this. What is the probability that a person with AIDS gets a positive test result? Person with the disease, and clock, that's my hot dog timing clock. Person with disease gets positive results on the test. Now, to be honest with you, one of the hardest parts of probability is taking a problem that's in real world language and converting it to algebraic language. So think for a second. What is the algebraic representation of this problem? Person with disease gets positive test result. I'll make it multiple choice for you. Is it the probability of D, is it the probability of D intersect positive? The probability of D given positive? Or the probability of positive given D? Think about that. Take a moment to figure out which of those 3 is the correct algebraic representation. Okay, here's the one that you should have come up with. The probability that the person with disease gets a positive test result. It is one of the givens. It's not the first one. It's not the probability that a randomly selected person both has the disease and has a positive test result. That's how it would have been worded if the first one would have been the correct algebraic representation. No. It is instead, it's given that the person has the disease. So it's the third one. What's the probability that a person has a positive test result given that they have the disease? Now, some of these slash probability problems come straight off of the tree diagram. They're already on the tree. You just have to pluck the answer off like you pick a ripe apple. And other times you have to really rely heavily on the formula. So if I'm doing this one, probably that the person gets a positive test result given they have the disease, that one, a lot of people might say, oh, it's just 0.8. But no. Positive given that they have, oh, actually that is positive given that they have the disease. That one is, that's just right there. That's what this means. It means the answer is 0.8. If I had asked you the question to what's the probability that a randomly selected person both has the disease and tests positive, and symbolized by intersection, that wording would have led to the leaf probability. D and P, you take branch times branch, that one would have been 0.08. But the really challenging problems are the ones where we flip this around. Problem number 3, this is a practice problem. What if I had said, what is the probability that a person with a positive test result has AIDS or has the disease? And this is the pressing question that actually comes up in the real world. You go in, you get tested. The person and you have a positive test result. The doctor looks at you in the eye and says, your test result came out positive. I've heard there's such a thing as a false positive. I wonder what the probability is that I actually have the disease. And this is the question to which the answer is not directly in the tree diagram. You actually have to use the formula. So let's find out why. If you were to convert this question into algebraic form, it would be the probability. Okay, I know I have a positive test result. Whatever it is that you know to be true goes after the slash. That's your given. So the algebraic representation is what's the probability that I actually have the disease, given that what I know for sure is that this doctor is looking me in the eye and telling me I have a positive test result. Look at formula central, formula number 5. It says that the probability of A slash B is the intersection over the probability of what comes after the slash. So according to formula central 5, that would be the probability of D intersect P divided by the probability of whatever comes after the slash P. So, you see, D given P, what's the probability of disease given P? It's not like the previous one, where, I mean, technically on the previous one, if I had done D intersect P, that would have been leaf divided by probability of upper branch. If I had used formula central, formula 5, it would have been leaf over upper branch. But here it's leaf over probability of P, which is not the upper branch. So what we have to do is, it's leaf, probability of D intersect P is 0.08 is the leaf. But the probability of P would have to be the sum of the two positive leaves. It's 0.08 plus 0.27. This is the probability that a person with a positive test result has a disease. And so in these harder problems, where it's not a matter of just picking the number off the table, what you have to do is view it as leaf D intersect positive. So take the dp leaf divided by the sum of the leaves. So when I say go, I want you to say out loud and in unison, leaf over the sum of the leaves. Ready? Oh, wait, no, I didn't say go yet. When I say go, I want you to say leaf divided by the sum of the leaves. Ready? Go. Leaf divided by the sum of the leaves. Okay, that's pretty good. Those are the harder ones. Okay, so now I'm going to hot dog quiz you. Here we go. This is the hot dog quiz. And it's a new tree diagram. Your tree diagram looks like this. Suppose we have a different situation in which disease complement. It turns out that in this situation, 80% of the people have the disease, 20% do not. Positive, negative. Positive, negative. This is a hot dog question. I haven't asked it yet, but here we got 0.9, 0.1, and this one over here is 0.7. I'll leave it to you to figure out what that branch has to be. I'm not going to tell you what the 4 leaves are in preparation for this hot dog question. If you want, you can fill in the 4 leaves. Okay, now let's just do some warm-ups here to make sure we're going in the right direction, to make sure you have this correct. Not a hot dog question, but tell me, what is the probability that people who test positive have the disease? Yeah, people who... Actually, you know what? That's not the hot dog question. Just want to emphasize that. But do that for practice. Find the probability that people who test positive have the disease on this table. Okay, now if you found the probability that people who test positive actually have the disease, that's disease given test positive, that's going to be intersection, disease intersect positive, disease intersect positive, divided by the probability of positive. Okay, disease intersect positive, that's going to be 0.72 over the quantity, the sum of the positive leaves. Positive would be 0.72 plus 0.08. So if this were a hot dog problem, that's what you would write on the hot dog sheet. Okay, now for the actual hot dog problem. Again, when you get it, put it up in the air, when everyone in your group has it, fold it, put it up in the air, and look at live sub. Live sub will either give you 1, 2, 3, 4, 5, 6, or 7 to indicate what order. And then, after 1 minute, you'll have 1 minute to do this problem. After 1 minute, you will... I'll call time, and I will announce the answer. Live sub will then go, live sub actually already knows the answer, and live sub will then go around and check to see if you have it on your hot dog sheet for your group. So that's the plan. You know what, just for fun, one last warm-up. What's the probability of negative given you don't have the disease? Last warm-up problem. What's the probability you test negative given that you have the disease? This one's kind of tricky in that it's not that hard. Negative given disease, friends? That's just right here on the branch. I mean, come on, that's what we mean by this lower branch probability. It's the probability you test negative given that you came down this route on the branch. It's just 0.3. So watch out. Some of these are right there on the tree diagram already, and then others you have to do leaf divided by the probability of the leaf. So here we go. This is the hot dog question. That was warm-up number 1, warm-up number 2. Number 3, here we go. What is the probability that once I write this down, I'm going to hit the timer. You're going to have 1 minute. All you have to do is give the setup. So it'll be, either maybe something like this or something like that. It's not a calculator problem. I don't want you to simplify it. Just give me the basic setup. It'll be either one that's right there. It'll be either a branch that you pick right off, or one where you have to do a leaf over the sum of the leaves. Okay, here we go. What's the probability that you do not have the disease, given that the test says you do not have the disease? Ready? Go. You have about 30 more seconds. Fifteen more seconds. Live sub is giving you the numbers. If you don't have the answer at 1 minute, you can still get participation points. 2 more seconds. Time's up, that's it. Video sub, thank you for your help. Video sub will be going around the room and giving credit for this answer. Based on Formula 5, this one is leaf over the sum of the leaves. Those of you who have the correct answer, keep that hot dog sheet up in the air. Those of you who have the correct answer are the ones who have disease complement negative. It's going to be leaf over the sum of the leaves, 0.06 plus 0.08. All right, so live sub is going around. Thank you, live sub. Nice work. Good job. High five. Okay. Now, friends, assignment 6.6 is due tomorrow. We'll see you then.